Hi everyone, this is Ms. Cesara back again with Unit 3, Ratios and Proportional Relationships. Today we're going to continue with Lesson 5, and we're going to do a little bit more with solving proportions, but today I'm going to teach you another method for solving proportions, which is called using cross products, or we call it cross multiply and divide. You can read this real-world example yourself, but we're going to come back to it in just a minute. First, let's talk about proportions. Now, we're missing a proportion here, so I'll just write it in for you. In the proportion, 2 is to 3 as 4 is to 6. This is a proportion. They're equivalent ratios. If you were to reduce 4 over 6, you would get 2/3. So that's how you know that these are equivalent ratios. But there is a special property called the cross product property. And what this means is that the numbers across from each other, if they were multiplied, you would get the same answer. Notice that 2 times 6 gives us 12, and 3 times 4 also gives us 12. And we're going to use this property to help us solve for unknown quantities in proportions. And here's the cross products property, just showing once again that 4 times 15 will give you 60, and 3 times 20 will also give you 60. Let's try our first example in our guided notes, and this example is 2 is to 9 as 3 is to D. Now, using the cross products property, we know that if we were to multiply 9 times 3, and we can just do mental math, that's 27, it's going to equal the product of 2 and D, 2 times D. So you could ask yourself, what number times 2 will give me 27? Or you could just do the inverse operation. The opposite of multiplying would be to divide by 2. That way those would cancel out. And 27 divided by 2 is 13.5. Because we have that cross product property, we can use a method called cross multiply and divide, or you may have heard it called the butterfly method. I'll do the butterfly method right now. We have 2 is to 9 as 3 is to D. All you do is find the numbers that are across from each other, and you multiply those numbers first. And it's called the butterfly method because we kind of get the shape of a butterfly here when we cross multiply. So 9 times 3 is 27. Write that number and go ahead and set up a division house, and you're going to put that number inside the house. It is your dividend. And then your divisor will be that leftover number. Notice 2 does not have a partner across from him, so he is left out. He is left out of the house. So we're going to do 2 into 27, and you'll also get 13.5. Sorry, that should have an equal sign. So D equals 13.5. Anytime you have a proportion, which is with two ratios that are set equal, so you're going to see the equal sign in the middle, you cross multiply and divide. Let's try an example. And this is the example we introduced the lesson with. At Space Camp, you can sit in a chair that simulates the force of gravity on the moon. A person who weighs 105 pounds on Earth would weigh 17.5 pounds on the moon. How much would a 60-pound dog weigh on the moon? We are going to compare the weight on Earth to the weight on the moon. So let's set up our proportion first. For the person, the weight on the Earth is 105 pounds. And their weight on the moon is 17.5 pounds. And now for the dog, we'll make sure to put the Earth pounds in the numerator and the moon pounds in the denominator. How much would a 60-pound dog weigh on the moon? So on Earth, the dog weighs 60 pounds, and we're looking for how many pounds he'd weigh on the moon. So we're going to use the method cross multiply and divide. 60 times 17.5, and that's going to give us 1,050. And then we're going to divide by that leftover number, which is 105. He does not have a number across from him, so he is left out of the house. And 105 goes into 1,050 10 times. So the answer is 10 pounds. The dog weighs 10 pounds on the moon. Let's try another example. This example is a little bit different. Let's read it together. It says penguins. At an aquarium, the ratio of rockhopper penguins to African penguins is 3 to 7. So think about that for a second. Your ratio of rockhoppers to African is 3 to 7. So let's just write out that information here and hold on to it and come back to it in a second. If there are 50 penguins, how many are rockhoppers? Now, because they are asking us to compare the number of rockhoppers to the total number of penguins, we are going to make sure that our ratio is our number of rockhoppers and we're going to compare it to the total. Now, the problem that we run into is our ratio is 3 to 7, our rockhoppers compared to African. So we want to compare our rockhoppers to the total. That's what we need to put into our proportion here. So how many rockhoppers do we have? We have 3, and then our total penguins will actually have to add our rockhoppers plus our African. So you can see they have done that down here. 3 plus 7 equals 10. So 3 to 10 is your ratio of rockhoppers to the total number of penguins. And then we're going to set that equal to what the information they've given us in the problem. If there are 50 penguins, so there are 50 penguins total, so we'll put that in the denominator where our totals are. How many are rockhoppers? So that will be our variable. And to solve this proportion, now that it's set up, we'll cross multiply. 3 times 50 is 150. And then we'll divide by that leftover number, which is 10. 10 will go into 150 15 times. So the answer is there are 15, sorry about that, 15 rockhoppers at the aquarium. Okay, now it's your turn. I want you to try this example, and then we are going to check your answer tomorrow in class. I'll read it to you. It says, in John's class, the ratio of boys to girls is 5 to 8. If there are 39 students total in his class, how many are girls? Just a hint, remember that you are comparing the number of girls to the total number of students in the class. So your ratios need to reflect that, girls compared to the total. See you tomorrow.